Hello, my name is Robert Auer, Director Global Business Development at TDM Systems, the tool data management software here at Sandvik. And yeah, I'm really happy to be here and talk to you about tool data management, the status, the outlook, what's great, what's exciting, what's new. I'm really looking forward to talk about that. Well, a tool data management system is basically the data backbone of the end-to-end manufacturing process. Tool data management system is distributing the tool data and it's connecting to systems along this entire process. The challenge in this process is basically that you have individual systems such as CAM, vending, presetters, machines. They all have their needs, their individual databases, different requirements for data. So they're basically island solutions. It's a very fragmented process with all kinds of challenges such as double data entry, lack of transparency, and so on and so forth. Studies, for example, have shown that operators spend about 20% of the time looking for tools, or that 15% of the jobs are delayed by not having the right tool at the machine, or 80% of the work is done with 20% of the tools. And I could go on and on. However, tool data management systems, on the other hand, are a central database. They're interfacing with as many systems as possible and thus providing the digital tool data along every step on this manufacturing process. Plus, they're connecting the digital world with the actual physical world. Therefore, I think it's crucial for manufacturing success because it minimizes tool-related machine downtime and the setup times. It improves quality and, of course, it enhances the overall efficiency and it reduces the tool costs. So in the end of the day, it's helping manufacturers to stay competitive. Accurate and well-organized tool data contributes to multiple areas. For example, by not having to search for a tool, you have transparency, and of course you have good quality tool data for CAM or simulation. Or you're transferring the tool offsets directly to the machine. You keep your stock levels up. I would say features like order-related tool balancing, automated shop floor management, or a structured tool crib management, they come to my mind. And of course, reduced supplier variety, increased tool availability, and tool reusage, because you have a transparent, structured tool crib management process. Well, in essence, a tool data management system basically makes sure that you have the right tool data, and the right physical tool at the right place at the right time, and of course, in the right quality. When I say data, I mean like a 3D model or technology data for a CAM system or simulation system, or the bill of material, stock location, assembly instructions in the tool crib. When I say parameters, I mean like a diameter, stick out length for presetting, or of course the technology data, tool life for the machine. And if you look even further, of course, manufacturing data analytics or historical data for quality control. Well, because different industries or companies, of course, benefit differently from a comprehensive tool data management system, it really depends on the area of, let's say, the customer focus. For example, if it's more on the planning side, like CAM, simulation, or more on the logistics side, tool crib or shop floor management, the results vary, of course. Let's say a good example for a success story for an entry-level solution providing the benefits through transparency would be a machine tool builder who, actually 1 year after introducing TDM, was able to reduce the amount of tool assemblies from around about 10,000 to 6,000, so almost cutting it in half. And that led, of course, to all kinds of benefits. Organizational, vendor variety, space, quality, cost, and so on and so forth, just by having full transparency about tool items, assemblies, and jobs. Or machine shop. The machine shop was able to reach almost 100% utilization of the machines by just having a transparent tool management and tool life monitoring process. What they did, they established a kind of a completely automated process for tool preparation from the tool crib to the machine, including technology data such as tool life, feeds, and speeds. They established a seamless tool lifecycle management, and the result was that the exact tool data is available at the machine, the remaining tool life is known precisely, and the tool demand is then calculated. A new tool can be prepared on time to the machine to avoid unnecessary tool-related downtime. The result, 100% uptime. Or, for example, a Swiss medical manufacturer is saving 2 million Swiss francs over 4 years. And with the exchange rate these days, 2 million francs is a lot. They established an entire end-to-end manufacturing process. They started in the planning area with interfaces to Mastercam and Vericut. Then they established a central setup station with an optimized logistics area and an interface to the Zollner tool presetter. That created a really smooth data flow with one database for all the systems. And then, as mentioned, the savings through standardization, harmonization, and optimization, they were just tremendous. Well, I would say we're just starting to see how AI and analytics changes the possibilities in tool data management. I really think AI and advanced analytics can be leveraged in various ways, like optimize and predict tool changes or for anomaly detection. A very good example would be tool life optimization, like monitor tool life, monitor speeds, feeds, the usage, wear, and inventory. You basically monitor and analyze the tools in real time, and then you get like a proactive decision making. AI will definitely provide real-time visibility, and you can make immediate recommendations or decisions based on the information, the actual information, and of course based on knowledge, on history, like adjusting machining parameters or ordering replacement tools. That can be done instantly. Or a more recent discussion I had this week is actually, let's talk about intelligent UI design. How can we leverage AI to create more intuitive user interfaces, multi-language, multicultural, including help functions like a co-pilot, adaptive controls, and so on and so forth. And there's so much more which comes to my mind, such as data creation, smart data analytics, virtual reality environments. But in general, I would say AI and advanced analytics in tool data management will enable the transition from a traditionally more reactive system to a proactive, data-driven approach. And that, of course, will even further reduce downtime, optimize tool usage, and then leads basically to cost savings and even improved overall manufacturing efficiency, which is what we're here for, right? And there is, of course, so much more. Also, if you look in the back end, like our generative AI, which helps the programmers to write the actual software, and this is really just the beginning. I think we live in really exciting times. Well, I would say there is still plenty to do when it comes to, let's call it the classic IoT and Industry 4.0 smart manufacturing projects. Basically, basic digitalization. We are not even close to the peak of this phase. My best advice is for companies to get started now. Even if you don't understand it all, that's what the experts are here for, and they will help you with. And at the same time, I hope that the move towards standardization of data, standardization of interfaces will continue. We still have a patchwork situation in the manufacturing world, especially the last mile into the machine. More standards would also help with the IoT, Industry 4.0 smart manufacturing projects, the ones I just mentioned in the beginning. There's still lots of untapped potential. It's a very conservative industry after all. Yeah. And I think if you look at new technologies, I think it's, on the one hand, it's business or distribution models like cloud-based solutions or software as a service, that's the one side. But then, of course, new technologies, such as blockchain for transactions, traceability, or AI and machine learning on the other hand. Especially the integration of AI and machine learning will become, I would say, even more prevalent in tool data management. Advanced algorithms for predictive maintenance or for tool wear analysis or optimize the tool selection based on real-time data and historical patterns. That's where we are going to. Either way, I would say the future of manufacturing is digital. And manufacturers and suppliers who embrace these trends, they will be better equipped to optimize their operations, reduce their costs and improve their overall efficiency while staying competitive in an ever-evolving industry landscape. Well, to summarize, or what you should take away from this session, I would say there's a lot of potential in tool data management. So if you haven't started, get started. If you already have a system, improve it. Work on it, make it better, improve your processes. Secondly, I think the current situation is including more systems like CAM, simulation, presetters, machines, get real data, live data from the machine. And as a third takeaway, I would say the future is bright. With AI, machine learning, there are a lot of exciting new technologies on the horizon. And you definitely want to be part of this digital journey. So get on board.